Good day everyone, and welcome to week 7 of the differential equations class. Here is the plan for today. So today we still are going to continue looking at second order differential equations, and in particular we are going to do models with second order differential equations. Here is what you need to review in order to understand today's lecture. So basically it's just the previous 2 weeks of our class. So let me help you to review this material. In the previous 2 weeks, we've been working with second order linear differential equations. So if the differential equation is homogeneous and has constant coefficients, then it is relatively simple and straightforward to solve it explicitly. So there are 3 possibilities. Right? The discriminant of the characteristic equation may be positive, so then the equation has 2 different real roots, and then the solution is going to be a linear combination of exponential functions. The discriminant may be 0, then there is a repeated real root, so then we're going to have a combination of an exponential function and t times the exponential function. And finally, if the discriminant is negative, it means that the characteristic equation has 2 different complex roots, and then the general solution is going to have sine and cosine. Well, then we have tried to study non-homogeneous linear differential equations, right? And then what we could not solve a non-homogeneous or general differential equation with non-constant coefficients, but we proved a few important theorems, right? So the first of them is that the formula for the general solution of a non-homogeneous differential equation if we know the solution of the corresponding homogeneous differential equation, right? So then it's just like in linear algebra. If we take a particular solution of the non-homogeneous equation plus the general solution of the corresponding homogeneous equation, then we get the general solution of the non-homogeneous equation. Well, and finally, if we have a non-homogeneous linear ordinary differential equation, then and suppose that we know how to solve the corresponding homogeneous equation, then there is the method of variation of parameters, where after some tricky computation we got this formula for u1 and u2, and then we can by using these formulas we can solve the non-homogeneous differential equation.